Today the topic is related to the AI. We have here Chris Meyer, which developed a first prototype of AI chatbot, and he will present us the technology he used and what was the outcome, and he will do also a bit of live coding based on your questions, so I won't steal him much more time. And thank you, Chris, for being here, and the stage is yours.
Okay, thanks, Stefano. Can you hear me if I speak without a microphone? Is it okay? Because I need hands to type. Okay, so this was the kind of more the marketing presentation. I have another one. This is maybe a little bit more funny. So basically the background story is that I was asked to see if we can use these large language models. I guess you know what those are, like ChatGPT, to assist the Open Data Hub team with their help desk work, where developers ask questions, can we do something along the lines of these large language models. To make it a little bit more interesting, I very strongly suggested to try to host them locally. So, well, locally does not mean that they must run locally, but at least self-hosted, so that you not rely on some API of a third-party vendor like OpenAI. I think that's very important and very interesting, because you might want to share data or documents with these systems that you are not comfortable sending to OpenAI. And the other point is that we would also like these models to be open source or free or whatever you want to call them. So they should have a license that basically is very permissive. Today I will try to bring up a few questions, a few problems I encountered, and hopefully clear a bit up some questions you also have about these things. First of all, if you ever looked into this space, you've seen that there are really many models available. You've heard about Llama 2 probably, which is one of the most famous ones. But if you go to a site like Hugging Face, where they collect all those models, you see hundreds, if not thousands of them. And furthermore, there is also a big activity. So there's new models each week or even each day, and the space is boiling with activity. So where do you start? What model do you pick? Then the next question is, okay, a free model such as, for example, Mistral, which we're going to use today, how well does it perform? Can it really answer questions in a way you maybe are used with the big commercial models? Okay, then there's the next point. As you know, the problem is you want to teach these large language models domain knowledge about your data. Okay, so it's very nice to ask it when Rome was founded, or I don't know, when was the First World War. This is all very interesting, but it's not very useful. Ideally, you would like to give a document to this model and then ask a question about this document. This is where the whole interest is currently. For example, Microsoft, as you know, are all crazy, and they put those models everywhere. You've heard about Copilot, etc. So the interesting thing is not so much the model itself, but how you can use it to ask questions about your documents. So then if you look into this, you see these all this fancy stuff about embeddings and vector databases, and there's this acronym RAG, which stands for Retrieval Augmented Generation. which is basically the one acronym that describes this task, to give some documents to a system and then ask a large language model questions about those documents. So what software should we use again? It's not so clear. If you Google this space or DuckDuckGo this space, you get a lot of answers. You've probably heard about LangChain or Llama Index, which one you want to use. I've looked into these things and I can give you some suggestion, or I can show you what I found works right now. I have here on this notebook a working implementation of everything using only open source models and code. I've also done it on a Linux box in the cloud. I can connect them so we can compare also how this runs on a notebook and how it runs on a server. This point here is in red because this is incredibly interesting. We here are in a special situation. For example, the documentation about the Open Data Hub is generally written in some poor English, like the English we in South Tyrol all speak. Yeah? And the questions are not necessarily in English. A developer that opens a ticket for the Open Data Hub asks the question in Italian and German. So we have a particular multilingual situation. I found this is quite unique in the world. It's probably not, but at least if you see the exposed projects, they are generally not dealing with these multilingual situations. You see projects that say, okay, I want to do RAG, and I want to do RAG in Spanish, for example. Then they need a model that speaks Spanish. They need to do these embeddings. We are going to see what these are in Spanish. This is all fine and good, but we don't need a monolingual model in a language that's different than English. We need really a multilingual situation. I want to ask a question in Italian, and the system should look up the documentation in English and then answer in some language that might be either Italian or English. And this is particularly challenging, and I looked a little bit into this. It's quite interesting. And finally, what hardware do we need to run all this? Of course, I can use some API, and then in the background there is a NVIDIA H100, where a single card costs like $30,000. But that's also not very practical for our somewhat small situation here. So I've also looked a little bit into running this efficiently so that you actually can run them on a machine that does not cost like $5 per hour or something in the cloud. Finally, I have a proposal, implementation proposal. It's not actually in production or testing stage. It is at this point some proof of concept and a proposal. I will present. The funny thing is that the NOI people were these days abroad, so they don't know yet what my proposal is. I should have probably talked to them before presenting it to the public, but this way it's a bit more funny, and there's more suspense. Okay, so my presentation stops here because I want to do live coding. So I will close this down and open an IDE. The idea is I've prepared a few files. Of course, these files are going to be shared. We are, how do you say that? We are always studying the presentation, and we will put it somewhere online. Stefano will do that. And when we do that, we will also provide a link where you can see all these files here, all these examples. My idea is that I will go one by one, show to you the step to finally make this all run, and you can at any time interrupt me. Normally here the policy is that one does a presentation and then there is the discussion round, but I would like to change that. I would like you to just raise a hand, or not even raise a hand, but just shout out, let's try this, and I will plug it in and run it immediately. Okay, let's see how this goes. There's one more point. I am quite short-sighted and this resolution is quite high, so I might do the old grandmother meme thing. So don't be afraid, I will find everything in the end. Okay, I start with this file here. Please tell me, can you read the text? Is it large enough? Okay. This is the very first thing. We need to try to run a local large language model. Okay. So we are not yet inputting our documents. We don't have these embeddings. We don't have vector database. We just want to run a local model. Now the question is, what software do I use? My suggestion, my recommendation is to use this software here. It's called Llama CPP. It's written by some very ingenious person, Gerganov. And this is, of course, one of many ways to run a large language model, but I found this very interesting. It's very interesting because it runs on all kind of hardware. You can run it on a CPU and it will do very efficiently. It is more efficient than some standard package like PyTorch. It does understands most GPUs. For example, it can use the GPU on a Mac also. It can use, of course, NVIDIA cards if you have CUDA. It can use on some systems, looking to Daniele, it can use AMD GPUs. It uses about everything. It has also other interesting things. It has its own format for large language models that is standardized. It's called GGUF. I don't know what it stands for. I think it is not known, but GG should be the initials of this person who programmed it. So the nice thing is, on Hugging Face, you get all the models in this GGUF format. So you have a unique format for all the models. Basically, you can run this and plug in a different model and compare models. And finally, it can compress models. The original models are usually released with 16-bit floats. So a model is basically a giant file with lots of floating point numbers. And this software here can compress it. It can use less than 16 bits for these numbers. So that's very good because these models are incredibly large and maybe you don't have the RAM to run the larger ones. With this compression, you can run larger models than otherwise would be possible on your computer. So this is something I really do recommend. It has a Python binding. You don't have to use Python actually. There are bindings for basically every language. I'm using Python here because that's where you find the most tutorials, and that's kind of the go-to language nowadays if you do all kind of data science stuff. But it's certainly not something that should stop you if you are used to program in another language. Okay, so I've tried these examples to have the minimum numbers of dependencies. I don't like it if you have these very long import statements at the beginning and you need 20 different open source projects. So I try to keep them as small as possible. You see all these examples here use just a few import statements. Look at this. It just imports Llama CPP. Okay, so what does this example do? Basically, this example tests interaction where there is a question and then a follow-up question. So you see here, these prompts work this way. There's first of all a system prompt. All large language models have a system prompts that you don't normally see. If you use the ChatGPT API, you don't see the system prompt. It's hidden from you. It says, how the system should respond, that it should be helpful and it should not do something offensive and all these kinds of things that are hidden. In this case, there's just a very simple one. You are an assistant who answers questions. It's very basic. Started with something very basic. Okay, then there is the first user prompt. I choose a generic question. Remember, we don't have yet any of our data in there. So the model needs to answer from things that it learned during training. Name the planets in the solar system, skip Venus. This is a small test. A very primitive model would somehow read Venus and then say something about Venus. This is a small test to see if the model is any good. And so it will answer something, and then I construct another prompt with a follow-up question, which is the answer from the system, plus the follow-up question, please tell me more about this topic. Okay, so this is the setup. This uses Llama CPP to do exactly this. It's nicely pluggable. You see I've made it that you can change the language here, so you can test different languages as well. And everything's fine. Now, we have the software. We can run out the models. The next question is what model to pick. This is actually really hard to decide because there are so many. I suggest if you start, maybe try Llama 2. Llama 2 is kind of the most popular model. It is by Facebook. It is a very permissive license that is technically not open source. There is some bounds. You should read the special license if you're a company. But basically, as far as I, not being a lawyer, understands, there's no company in South Tyrol that would not be allowed to run this. So it's a very permissive license, and it's probably a go-to model. I've here chosen to use a format that uses 5 bits. 5 bits is kind of a minimum to have it working well. Remember, the original model was published as 16 bits. 5 bits is according to me, working quite nicely. You can get these models from Hugging Face. If you're new in this space, you might not know Hugging Face. Hugging Face is basically what GitHub is for source code. Hugging Face is for models, all kinds of models, not just large language models, all kinds of models. So you can download it here. Okay, let's go back. I've played a lot with these models. I tested other models. Currently, I'm quite in love is saying too much, but I like Mistral. Mistral is a model by a French company. I have the bookmark here. Let me quickly get it. Where is it? Mistral, this is a French company that published this model. It's a 7 billion parameter model under the Apache 2 license. And they say it performs better than a 13 billion model by Llama 2, and I sort of agree. I quite like it. Maybe Llama is a bit better in answering in different languages. Mistral understands German and Italian without problem, but cannot really well answer in Italian or German. Llama is a bit better also in answering in German or Italian. But otherwise, I think Mistral is faster. It's smaller, faster, and somehow, it tends less to hallucinate things. I don't have a formal benchmark, but I quite like it. Of course, you can get the formal benchmark from them. They say basically what I'm suggesting now, that they can beat Llama 2 13 billion. There are larger models available. There's a huge Falcon model, and there's a 70 billion Llama models. But these tend to start to be a bit cumbersome because you need a lot of resources also to run them. In my experience, these kind of mid-sized models such as these are starting to be quite good. I think the future is around this space here. I don't think that you need really large models for now. Probably in a few years we are going all having to have 100 billion models. But right now, I think these are the models where the research is happening and where all the action is happening. Okay, so that's it. I've here picked Mistral, I've picked the software, Llama CPP, so I can run this now. You see the code is not very long. There's basically just some prints to see what it says. Let's run it. Currently I've switched to Italian. Let's maybe run it with English, like this, and I can here do run. If I find it, run. This is now running locally. I've downloaded the model, the path of the model is there, and you can see the first answer, already quite correct. This is coming out of the model in order, blah, blah. You see the planets are there. I think they are correct. This is also one reason I like Mistral. It's kind of nice. It says, well, there would be Pluto, but they unfortunately declared it not to be a planet anymore. And of course, us older guys all learned still Pluto being a planet. Okay, you see this took just 3.9 seconds. So it's pretty fast. It's actually using the GPU here, so that's that. But it's very workable. I mean, you can expect, you can wait 3.9 seconds. I think it's not a problem. Then comes the follow-up question, tell me more. And in the follow-up question, the model answered with this here. And that took 29 seconds. It's pretty fast. You see that the time goes up because the answer is longer, and the input was also longer because the input was the previous answer. You always have to concatenate this. So yeah, it goes kind of linearly up with the number of characters it puts out. But it's quite workable. Okay, so is this correct? Well, not really. For example, this one is quite correct here. Llama 2, for some reason, always mixes up the order. This looks to be good, actually. Yeah, should be correct. If you look into it, and now I don't remember exactly where it is, you see some weird things. Of course, you can run this with another seed. You will get a bit another answer. There tends to be some errors in there, but so generally speaking, it's quite okay. There's no big hallucinations. I've seen Llama does this a bit more. So Llama might, for example, mix up this order here and say Mars is the 7th planet because it somehow can't count. Mistral is quite good. Okay, so that's that. We can run the model. And we can run it with basically a very simple Python dependence. Now you say, yeah, I don't have a Mac, and this is also strange to me, no problem. We can move to a Linux box. This is here the server. I have exactly the same code on a server running also. There's just the Python that came with Debian 12, and the other one is the Python that came with the Mac, and then this Llama CPP. So there's no other dependency or strange things happening. Let's move here to the right place. I will leave this open then. I've prepared here a Python virtual environment. Let's do that. And I can run the same thing here. 01 chat by. Okay. You want to try out something? Let me know. I leave this running. The server is a little bit slower. I will have timing comparison in the end where you see the whole pipeline, what the timing is. So you see the first answer here comes after 9 seconds, and the second answer will take more than a minute. Again, interrupt me if you want something to try. I have prepared here a bit of a summary. So, yes?
Excuse me, if you repeat the test, it will give the same output?
Yeah, because the seed is the same. But if you change the seed, it will give another.
Ah, okay.
Okay.
It is
There is a random seed. Here, there's a file. There's basically a markdown file included in the set of files I will distribute and share with you, where you can see the answer in different languages of the different models. So this is a kind of systematic test where we have Llama and Mistral and all three languages. You can compare the languages. You can see what happens. So, for example, here, this is a Llama that mixes up this order, for example. Quite interesting. Earth is the 5th planet, which is, of course, not true.
Only with this seed. If you change the seed, you get
If you change the seed, you might get another mistake somewhere else. It's kind of fuzzy. Huh? It's not. You can't use this really for super critical things. Huh? It's a bit like Tesla self-driving. I should not have said that on YouTube, because now I'm getting sued probably. But yeah, well, it works. It works until it doesn't. And this large language model currently are at a similar state. Of course, this gets better all the time. If you take some Mistral model or some Llama 3 is now close apparently to be released. Llama 3 will make this better. It's improving all the time, but it's not something you can rely your nuclear reactor on. Okay, so here you see the language test. You see, this is Italian. Here comes Mistral, Mistral in English, Mistral in German. Mistral understands languages, but speaks languages not really perfectly. You see, this is a little bit of a problem. If you want the answer in correct German, you're going to have a little bit of a problems here. There's a word that does not exist, and it tends to switch language. For example, here in the second prompt, it forgot that it was supposed to speak German and switched to English. This can happen also mid-text. This is the Italian one, also quite interesting. The Italian question was understood, but the answer is completely English. So somehow the model does not feel comfortable answering Italian, it answers in English. This is, of course, very important if you have the necessity to output this language. What could you do? You could use a larger models. If you use, please.
But is that then switches the language? Is that a conscious decision? That it kind of is like, okay.
It's certainly not conscious. They're not in that sense.
Is it like, is it a glitch in the system? Like it should be that way, or does it decide to rather speak in English?
No. This is glitching. This is probably a word that is or a grammar structure that somehow is close to English, and so as it was trained mostly on English, it somehow switches to English. Because don't forget, these systems are, in a sense, still stochastic parrots that just repeat the word patterns they see. You would probably need right now to switch to a larger model. Probably Llama 2 70 billion would be able to handle these output languages better. But I'm quite sure that this is being improved all the time. So don't say, okay, it does not work, forget it, and then go away 5 years, because you should retry in a month or two, because this is really improving so fast. Okay, so here you can look up these things. I will not go into all the details because time is, of course, what it is. Next step. Now we have this model running. We can test it nicely. You see it took 29 seconds or 43 seconds on the server here. In the files there's also the specifications here. You can compare these machines. These are not expensive machines. This notebook is not the highest end notebook, and also the server is just a plain 8-core server without the GPU. So I really paid attention to not use super hardware that is maybe not realistically available. Okay, so now we need to bring our documents into the mix. I want to ask questions about Open Data Hub, or for example here I played with Dracula. I have Bram Stoker's Dracula here from Project Gutenberg. and I want to do specific questions about my documents. From the Open Data Hub, I have a PDF here, for example, with some explanations, and I have also the wiki site. Here is the PDF. So this is there's some technical documentation inside here, and the wiki is about the same. Let's see what happens if I try to put these documents into the system. Now, basically there are two techniques to do that. One technique is fine-tuning. You take the model and train it further on your documents. It's called fine-tuning. In my humble recommendation, forget it. It takes too much compute power. You can maybe do it if you have a very static set of documents and want to somehow construct a model for your domain. Maybe you can do it, but for our smaller use cases where we say we have our set of technical documentation, we have our wiki that we want to import it, forget fine-tuning, it takes too much resources. The second method is use this context. If you remember the first example here, we can we have these prompts. They are called context. For example, if you ask the second question, which is the prompt number 2, please tell me more about this topic. Before that question comes the answer to the first question, and that is the context. Or before the first question, you have the system context. You are an assistant who answers question. That's called context. So what if we just give our document into this context? What if we tell a system, you are an assistant, this is the information I give you, colon, then we paste our document, and then we ask the question. Yeah, this works, but there's a problem. As you've seen, runtime goes up with context. So you can't put your 1,000 pages there because it would take ages. And second, the current large language models have a limited context window. They forgot what you told them. A bit like a human, if I tell you 1,000 pages and then ask a question, you forgot what was on page first, or page 1. So here's the same thing. This does not work because your documents are too large. They don't stay in the context. So what is the idea? The idea is that you do a little bit like a search engine. You set up a system where you take the question and somehow Google the question inside your documents. Then extract pieces of that documents that somehow matched your search and give them into the context. That is the idea. That is RAG. This retrieval augmented generation. That is the whole trick. Now, we are going to do that at number 4, but we are not there yet. We first must understand how this search works. I've made here an example program again. This is actually quite hard because how would you do that? Well, a very naive approach is that you could do full text search. You could pick the words in your question and just full text search them in all of your documents and find the pieces where these words appear and put them into the context of the LLM. The problem here is that does not work very well. You have all these semantic search ideas. Somebody asks about a cat, but the document is about the family of Felidae, and full text search does not know that a cat is a member of the Felidae. Okay, so what do? At some point, people started to build this rule-based system, these ontologies that teaches the system that a cat is a Felidae, but these are not very practical. This turned out not to be working quite well. So people came up with another idea, which is this BERT thing, this embedding thing. There was a paper by Google about BERT, B-E-R-T, which introduced this idea. Let's take a text and reduce this text to a set of vectors. This is a little bit like face recognition. Face recognition is now a sort of a solved problem. How does it work? You have a system, a neural network, that translates the image of a face to a vector with usually 128 numbers, floating point numbers. This is basically a point in the vector space with 128 dimensions. And you train the model in such a way that different faces have vectors that are as distant as possible, and as different photos of the same face have vectors that are as close as possible. Then if you do face recognition, you just need to transform one face into this vector representation, and then quickly query all the other faces you already did this task on to find the closest match. I think Google came up with this idea for faces, and the same idea was done for text. If you can do it with a photo of a face, you can do it with a text as well. Of course, there's some neural network that nobody knows how this works, but it works. What these things are called, they are called sentence embeddings. So you take a sentence that can be a few sentences, does not have to be exactly one sentence, and condense them into these vectors. This is called embedding. In the jargon of machine learning, this dimensional reduction is called embedding. And it turns out that this is also strangely working very well. I've again here an example where I took a few texts. You can see here this is a text about cats. I took the Wikipedia entry in 3 languages about Felidae and took the first 5 sentences each. This is what you see here, in 3 languages. And then I took, in the same process, the Wikipedia entry to microprocessor in 3 languages. And then I have 3 questions. The questions are about microprocessors indirectly. I ask about the applications of semiconductors. But the trick is, the word semiconductor or Halbleiter does not appear nowhere in this text, neither in the cat ones, obviously, although probably cats are secretly robots, and not on the CPU ones. So in full text search would just be lost because it has no idea. I mean, full text search would skip these words because they usually full text searches skip the stop words, the common words, and then it would not find the Halbleiter, and it will go nowhere. Let's see what this system does. Now we have another problem. We again need a software and we need a model. The software in this case is quite, people seem to quite agree that there is a package called Sentence Transformers that does this very well. So I'm using that one. Again, there's just a single dependency. And which model? That is a bigger problem. Alora, yeah. For the space of RAC, people are using very much this model here. It's one of the popular models if you do RAC. It is MIT licensed, small model, just 130 megabyte from some researchers from Beijing. And officially, it just understands English and Chinese, I think. It's not multilingual, but it works very well. I can confirm that it works very well. You can use to sentence embed Italian or German, it works. I don't know why, probably they also don't know why, but it works quite nicely. I looked into the multi-language thing. I found 2 models that are officially declared to work for multi and mixed languages. This one is by the same researchers, but it's huge. Look at this, it's 2.3 gigabyte. Well, it is trained on 109 languages, so in a way that's also justifiable. And then I find also this LABSE. This is a variant of BERT from Google that has been trained on also many languages. This is also huge, like in the same order as this one. So you see, if you want to do many languages, it starts to get bigger. I've made a few tests. According to me, the best one is this one here, the BGE M3 one, the largest one. It's the best one, but this one is really close. This is not much worse. So I suggest, if you want to rack like 100,000 Wikipedia pages, maybe try this one because it's a lot quicker. If you just have a few thousand pages, maybe use this one because it's maybe a little bit more precise. Okay, let's try this out. What I did here is I sentence transformed these 5 sentence blocks, each single sentence here, so not the whole block, but this is 5 vectors, and also the 3 questions. The interesting question is now, if I want to find the closest vector to this question here, what will it find? Ideally, we want to find it the Wikipedia articles about semiconductors, about microprocessors, right? Okay, but look at the language. Will it find the English texts? Because it says, well, this is English, so it matches the English one. Something that a naive job would do. A naive job would see, okay, these are English words, so I find them in the English text, I match those. But this is not what we want. We want to do something multi-language. So we want to find the microprocessor text here. So if I do this and then find the distances in all these vectors I get, will they sort in a way that this is closer to the microprocessor one? Will it skip the language barrier? Will it still associate the German question to the English text about microprocessors? This is what I want. And I've not found this anywhere online. And nobody has this problem. It's kind of a South Tyrolean problem. Huh? This I want to ask a German question about an English text. Yes?
Sorry to interrupt right here, but currently I actually use Copilot on a daily basis, and I very often actually ask also questions about documents that I'm reading currently. And I also ask the question in another language that is then the document is written in. So that's basically the same idea, right?
Yeah. The difference is that if you use Copilot, they use GPT-4, which is some 1,000 billion parameter model running in some huge data center. I want to do it here, now, with a free model. And that's the harder thing here, of course. Okay, so I've run this. I can run this. If I run this, this example here, you can run it at home. It will produce, it will be very quick, so let's run it. It will produce files. It will write this information to CVS files. And we are going to have a look at these CVS files. Okay. So you see here a warning. This is something that has to do with the Mac Python. The Mac uses LibreSSL instead of OpenSSL, and the Python library says it is an unknown implementation of OpenSSL. It's a known problem. Here it updated the model because this library, if you just give the model name, it looks it up on Hugging Face and downloads the latest model. Fortunately, the download was already made, but apparently they updated the README, so it re-downloaded that. But you can also tell it a file path so that it does not go online at all if you want. It's not mandatory that it phones home. Okay, so it does this. It's very quick. Of course, these are just 33 sentences, which is nothing, so it's very quick. Just done it. Written to CSV files. Let's have a look at these. I open one of them randomly. Okay, so now compare the vectors. The problem is this is a very high dimensional space. These systems use at least 384 dimensions. So there's somehow an overview here about who uses how many. I think I have that in one of these files. Let me see. Well, I say it 384 for the small model, or for what OpenAI does, this ADA network that OpenAI uses as a default, or 1024 for this very large model. So this is a space with 1024 dimensions. So there's a lot of space there. Okay, we can't compare this by looking at the numbers, of course. This would be completely without sense. So let's have a small detour. I prepared a small MATLAB script. This should have been translated to Python, but I did not manage to translate it to Python, so I have it in MATLAB. And it produces, what does it do? It tries to cluster these vectors, because I want to see whether my 3 questions cluster correctly with the microprocessor articles, what I want, and not with some random sentences, or maybe with the Wikipedia articles in the same language, because this is what you expected from a naive system. Okay, so I cluster this. I also want to visualize this, but you can't visualize these high dimensional spaces. So I used a well-known statistical method with this, which is this TSNE algorithm that can reduce any high dimensional entity to just 2 dimensions for plotting. But don't be too deviated by this plot. This is just as a guide to the human eye. The important thing is that we want to cluster these. The clustering is done by k-means. This is the reason I do it in MATLAB, because I can just call k-means. MATLAB is one of the easiest things to quickly test something. And I can run this, and it will produce, here I have the name of the file. You see, for example, let's pick the good one. Let's pick the BGM3 one. Here we go. Run this, and we get this output. This is, of course, now pretty nice. No, I will not show it like this. I will zoom it like this. I like this. This is nice. So what you see here is, first of all, below here, you see the result of k-means, which is the cluster. The clustering identified 2 clusters, which is correct. We have microprocessors and cats, so 2 clusters. The clusters are labeled 1 and 2, which is just the idea. And these are the sentences. The first 15 are about cats. They got 2. And you see there's no mistake here, all exactly 2. Then there is a line. And the next 15 numbers are the cluster IDs of the next 15 texts about microprocessor. They got 1. All correct here. There was no mix-up between cats and CPUs. And then there is a line, and these 3 are my questions. And as you can see, it put the questions correctly into the 1 cluster, because it understood that these all have to do somehow with microprocessors. So this beats full text completely. You need this, otherwise it does not work. Yes?
The color of the plot.
I'm explaining this now. The color here is not the result of the k-means, but the color is made by me. I've used the red one for the Felidae, the cats, the blue one for the microprocessor, and the black ones for the question. Yeah. I've also done the different languages with different shapes.
Do I see wrong, or there is a blue one in the middle of?
Yes, this is wrong here, but this is k-means did it correctly. This is DSNE. DSNE, because these points here, they have 1024 dimensions. And DSNE is mapping them onto a plot. And DSNE is not how do you say that? Stable algorithm in that it does not give the same output for each run. If I run this a few times, you will always see a little bit of variation and points running around. But the more important thing is k-means, which in this case is correct and is mostly correct. If you run this, here you see if I remove the random seed, this is the default seed of MATLAB. If I remove this and run it again, you will see another situation each time I run it. You see? It's a little bit different because DSNE and also k-means is not stable. Stable being the term to say that it has the same outcome with the same run. But the point is, if you try this out, you can do this 100 times and look at the k-means, and a few percent will be situations where one is mixed up, but not worse than that. So basically it works very well. This model is great at computing these vectors with the requirement that they are close to the text you want to give to the model. So this basically some years ago there was this semantic search. What was the keyword? This would be semantic search in a way. Nowadays nobody calls it semantic search. Nowadays it's called vector embeddings, because somehow these are buzzwords and they change all few years. But it's basically the same thing. Well, it's not the same thing. It's this is one algorithm that gives you the possibility to do this semantic search. This is the one we need. Okay, so we are a step closer. We can take the question and we can find the documents and the pieces of the documents that talk about the question we are stating. Nobody, of course, forbids you to do classic full text search. If you want to use full text search to find the documents, be my guest. There might be special situation where full text is better, because if you're looking like if you're using a system like a search engine, maybe you want full text search because you want to find exactly the match of that string, and of course you can do that as well. But mostly for more general purpose, this is the way to do it. Okay, let's go on. Now we need to do this with our documents. So now we need something that reads the documents, parses the documents, chunks them, pieces them up into pieces that are small enough that one piece can fit into the context of the large language model, and applies this vector embedding thing and stores those vectors. You could all do this by hand, of course. You can use a few days of programming and you would get a system like this. But again, there is software that does this for you. And the software I have seen that I sort of recommend here is this one, Llama Index. Here you go. Llama Index is kind of a Python library that is a glue code that does this step and more steps that are needed for ragging. For ragging, rag means doing this this whole thing we want to do, prepare these documents for the large language models. Here is some explanation. There is some suggestion why to use Llama Index. They say, okay, fine-tuning is too expensive and you can't quickly update the systems giving more documents, and what you can do with that, etc. And they also explain a little bit this rag pipeline here. There's a graph in there that is nice to understand a little bit the idea. So now we are getting closer. What we want to do is we take these documents and index them. They call it indexing. In the software is called Llama Index, which is in our case is this using this embedding. But again, use something else if you have something else. Okay, so the user does the query. The system finds in the index the texts that are close to the query and constructs the prompt that is fed into the LLM. The prompt has the user question and the pieces of text that are relevant. The LLM does its magic and gives the response back to the user. This is basically that. We've seen this step, that was 0, 1, how an LLM can respond. And this step we've just seen now with our cats and CPUs. Now we use Llama Index to combine all these steps. Llama Index does also the prompting, so we don't have to care about how to construct this prompt. Okay, but first we need to load our documents. Let's do that. What documents do I have here? Okay, let's close this one. I have, for this case here, I have the wiki from the Open Data Hub. The Open Data Hub has a wiki with about 130 pages. They are not long pages, they are nice chunks with questions about, maybe Stefano can tell you more how this came to place. I think these are just the Open Data Hub developer that built these wiki pages. So I choose this one.
The guide that the developer of the Open Data Hub developed, and on the frequently asked questions that are customers.
Okay, I've tried the PDF I've showed you, and I've tried these, and these work better. Maybe I talk a little bit later about why I think these work better, but these work quite nicely. So I'm going to load these and vector embed these texts. Let's so call load. Load will use the same large thing you've seen here. I could use the small one here if I wanted to be quicker, or I could use leave the large one here. So again, we need this model. I will run this. There's always this SSL warning. Okay, so this is the step that takes longest in all my demos here. It now goes over those documents, chunks them up, sentence embedded a chunk, and, oh, I forgot to say, where do we store these things? We need to store these vectors somewhere. Huh? Where do we store this? What is this block here, index? Well, as you know, if I do some presentation about any topic, I always use Postgres. So again, here you have the choice. You just need some kind of data store where you can save the information. Maybe you want to save the file or the path or the URL or something, in this case the path, because you want to keep the reference. You want the system maybe to give the reference to that document. So you need to keep that. And you need to keep those 1024 vectors. And yeah, you can use a lot of different databases. They recommend to use a database that can compute the similarity of vectors, because then they can make a query and say, give me the vectors that are closest to this vector. So probably you can't use any database. You need one that has this vector support built in, and Postgres does have that, because Postgres can do anything. And so that is something I used, and I think it's a nice system. What is important is here we have 130 wiki pages that come about like 200 something chunks, because they are quite small. Think like half a page or something if printed. And so the problem of fast retrieval is non-existent, because for a database a few hundred records is absolutely nothing. Also a few thousand records are nothing. But if you have a large volume of data, millions of chunks, you might want to use Postgres indexing possibility, because Postgres can index multidimensional vectors. So it can quickly find the matches. If you have more than thousands, please do that, otherwise it's slow in querying it. For our case, it's not even needed. Okay, in the meantime, this was done. It took 77 seconds for those wiki pages. I think that's quite fast. I don't see a problem there. We can, for example, here quickly see how many these were. Docs ODH wiki. Let's do a word count here, for example. These are just 5,000 lines. I don't know how to do this better, maybe like this. So just to give you an idea, this would be 5,000 lines and 225,000 characters. So it's not very large, but it's a decent size. I did this in 77 seconds. If I used the small model, this was just a few seconds. So you can index this thing quite fast. This is no match for fine-tuning. Fine-tuning, besides the fact that these are too few documents to do fine-tuning at all, would take days if you had more documents, of course. So this is absolutely way faster. So please go home and use RAG and don't do fine-tuning for your small use cases. Okay, now we have this vector stored. Let's have a look at these vectors. I think I made a mistake. I have them now twice in the database, but that is not a problem because I already prepared this run. I can show you. This is the table, data rack. Okay, so it's a table with the original text, some metadata, and these embeddings, which is a vector with 1024 dimensions. We can count them. I think they are twice now, but this is not a problem really. From data rack. Okay, 3 times I think, because here was written we have, no, twice. Okay, they are a bit more. They are 380, I said 200, it's a bit more, 380 chunks, and they are now in the database twice, but this is not a problem. So we have it here. You want to have a look, we can have a look. Somewhere there I've already prepared a query to get it out in a somewhat more interesting way. So this query extracts some metadata. So you see how this is stored. So the file name and the page label. In this case there are no pages, so there's a null here. For the PDF you would see the page. This is kind of metadata that depends on the file type. So Llama Index has different readers. It understands the file. You can read text, you can read PDFs, you can read Markdown, all kind of readable text. And the metadata change a little bit according to the file type. For example, here we don't have page labels for PDF, we have the page. Here we have just the file. Okay, so yeah. Basically, of course, I'm not showing the vector because it would be a lot of numbers. I'm not interested in that. Okay, we've prepared the embeddings that we can now give Llama Index and ask it to find the matches for our question and match it and ask the LLM to do its jobs or its job. Finally, we get to this point here. We have the fourth file. Okay, so again, not many dependencies. Well, they are imported below, but they are basically just Llama Index. Everything is done with Llama Index and of course Llama CPP for the model. Okay, I used a large model. I need to use exactly the same model to embed my question as I used to embed my documents, of course. If I change model here, there will be no match because different models give different vectors. So this is, of course, done. Then I need to give it the model here. Again, I use Mistral 7 billion as in the first example. Again, this is pluggable. Made a few comments here. Okay, this is some glue code It's basically copied from the Llama index tutorial, nothing special here. This is the connection string for Postgres. I need to give the dimensions. Oh, here's the line I did not find before, but this is the different sizes for the different embedding models. This I need to give to the system. It will generate the table like I say here, so it will call it data underscore in the name I give here. You can put different set of documents into different tables. You can mix it, no problem. I've tested to make one table with Bram Stoker's Dracula and the Open Data Hub wiki, and this is absolutely no problem. If you ask a question about Bram Stoker, it will answer looking into the Bram Stoker documents. Of course, this is what we've seen. It works. So you can put everything in one table. You can have different table with different domain knowledge. Okay, so yeah, this is a bit of coding you need to do to glue everything together. Basically, these are all kinds of initializations, and then we go to the actual job of running the query. Here are different queries I tested out. The query I left for the demo, but again, we can put in whatever you ask, ist in der Mobilitäts-API oder in der Mobility-API, welchen Wert für den Limit-Bar-Anwender muss ich setzen, um alle, this does not scroll, um alle Resultate zu erhalten. Okay, so if you don't know the Open Data Hub, it's some kind of API where you can query stuff via web interface and you get data back. And there's a lot of details, and this is just one detailed question. Of course, if I ask this without REC, Mistral would respond with something completely hallucinated because it has no idea what you're talking about. Huh? Especially note that I don't even say the name Open Data Hub here. I just, what a user would do, a user that gives a ticket to the Open Data Hub would not repeat Open Data Hub. It would just state it something like this, probably worse than this. This is actually a very clear question. Okay, so that's it. And then I print out the results. I researched a lot into these prints here because they are not in the tutorial. You need to deep into the system to understand them. These are quite nice because they show you different things. They show you the documents it found, the score it had. In this commented part, it shows the prompts the system gives. This is also quite interesting. Let's uncomment this. So we have a bit of extra information here. You don't need this for daily use, of course. And I'm going to run it. Run. Okay, so now the magic happens. This is faster than the RAG thing, actually. I always give the timings here. You see the model, the embedding model is actually quite large. It took 3 seconds just to load that model. Okay, and here we have the output. So what happens? First of all, I print the source nodes, the node that matched. Here we have the file path, the node in the database, and the start of the text. You see there's something about limit -1. So it really took the right chunk. Somewhere there it's written that you have to give -1 to get all the data. And it found it. That's the score. Actually, there should be 2 now. Why I see just 1? I don't know why I see just 1 here. Normally, I've said that it should look up 2. Maybe it's interpreted as most 2. These are the prompts. This is just out of curiosity. Very interesting how the prompt is constructed. You have a question and then you have a refined question. And you see how this works. The question is template. There's templates there. Okay. Here it comes. There it starts. Context information is below. Note I'm doing the prompting in English. If you want to be sophisticated, you should also change the language of the prompt, but anyway, the texts are all in English, so I guess English is the best thing here. Context information is below, then it puts the context, which is the piece of text it got from the vector database. Given the context information and not prior knowledge, answer the query. The query is what I ask. Answer, this is the prompt to give then the answer. So note this very interesting formulation, and use the context information and not prior knowledge. So please don't hallucinate stuff, but answer what you've written there, or what you've read there. Okay, and then there's also a follow-up thing. But now you're all waiting for what was the answer. The answer was, here we go. Alle verfügbaren Ergebnisse in der Mobility-App zu erhalten, muss der Wert für den Limit-Parameter auf -1 gesetzt werden. Perfect. It's even German. This is it's luck. It could have been English. As I said, the output language is always a bit a matter of luck. If the answer was longer, it would probably, knowing Mistral, it would have switched to English at some point, because Mistral tends to do that. Anyway, this sort of works. Eureka! We kind of made it working. I have here a bit of statistics for you to look what happens if you do different things. So there are some sample runs here. I've also put the timings there. So this was the timing to generate the embeddings with the large model. Again, with the small model, this was just a few seconds. And here are some example queries. Let's have a look. How can I access data related to the A22? That was a question that gave Stefano to me, because apparently there's a trick there. You only get the data if you authenticate. So there's actually a trick here. I validated this a little bit here. I have given a good to this one. The data related to the A22 can be accessed through the open API using a program authentication process. It's quite okay because it stresses this authentication process, which is the key argument here. We komme, opala. I know why this is bad, because my question was bad. We komme in an die Daten da. This is wrong German. This was my fault. Wie komme ich an die Daten da? Okay, this was actually bad in the answer, probably because also my question was bad. I am realizing now that I made a mistake in the question. This is quite bad. It found, here I showed the two documents it found, the getting started and flight data, and it says something that probably is too deep. It does not tell you you need to authenticate. It gives some code pieces, but I don't think this is good. Come posso accedere ai dati della A22? Italian, this was very good. And even the answer was Italian. Per accedere ai dati della A22 devi autenticarti utilizzando Keycloak, which is correct. And this is of course also quite nice. You can send a questionnaire. I mean, if this is used in the ticketing system, the NOI guy will laugh, because it suggests just ask yourself. Okay, so here's another one. Come posso ottenere dati su eventi turistici nella data zona? I'm mixing languages on purpose. This is also quite correct. To obtain data on tourism in a specific area, you can use the Open Data Hub Tourism API starting point, which is correct. I've looked into this, and it gives me some Swagger interface where I indeed can query events, so looks good. And this was the question I left in the open in the file. This is also very good. It just says that you need to set this to -1. So it sort of works, but it's not guaranteed good, and it has still it works very well in understanding the question stated in any language you want from the free we're using. That works well, but what does not work well is the guarantee that the answer language is the language you want. Please.
But shouldn't that be trivial to solve? I mean, like there are good models to detect languages and
And then
just do the
translate it.
translation.
Yeah, you can work on this thing. I also thought about manipulating the Llama index templates. And in the template where the prompt is constructed, add please answer in that language and no other language or something like that. I guess you could work a little bit with this. But don't forget that generally speaking, Mistral kind of speaks Italian, but very bad German. So yeah, you don't want an answer in bad German as well. Please.
What about if you ask something completely out of scope? Does the
Yeah.
model tries to answer anyway, or does it?
Okay,
say,
so
"I haven't found the answer"?
that is actually a brilliant question, Stefano. It's a rhetoric trick. You always need to load the question. The point is, in the prompt, there is this information, as we've seen, answer, only relying in the context, something like that. And in a few tests I made, for example, I asked about Bram Stoker on the data only about Open Data Hub, and I've seen that indeed says, I don't see it in my context, something like this. But we will try. Please give me a question.
Who's the current president of the United States?
This is probably quite dangerous because this is something it knows from prior knowledge, I guess. So we need to see what it does. I can't type because I don't see anything. I'm too short-sighted to type here. Who is the president? The current president, you said? Current president of the USA. Okay. Question mark.
You have a typo in the variable name.
Yeah, I've seen it. Thank you. Okay. Let's do it. What is the context here? Yeah, it's the right context, so I can do Ctrl R. I can't find the line. Okay. Yeah, this worked. I cannot answer the question based on the provided context information as it does not contain any information related to the current president. This works. If I gave this question without the RAG pipeline, it would probably tell me a name or hallucinate a name. Let's plug it in into the plain model without the RAG pipeline, okay? That's a nice experiment. So where was that? Okay. Let's copy this and put it into the first one. Okay, so let's pick the language. Let's pick the language English and just plug it there. Let me see how I can do this quickly. Probably the quickest thing is to not break anything and just do it like this. I can't see my mouse pointer, so I need to rely on the keyboard. No, this stays the same. No, this is the system prompt. I should not touch the system prompt. I've copied the wrong one. I should copy the user1 prompt. So let's do that with the user1 prompt. And this I don't need because the system prompt remains the same. And the question, I cut the question, so I need to copy it again. Sorry for the slowness. For query by, here we go, copy it again. And where is this one? No, this was the wrong one. This. Okay, prompt user 1. Okay, this is saved. I can put it here. Okay. Yeah, now I have the double quotes that mess up the IDE. Here we go. Okay. And I run it. I need to run it again because in the header now there's still the other one. Okay. So my guess is here, from experience, I would say it hallucinates or says a name. Maybe it's the previous president or something. No, the president is Joe Biden. Okay, I don't know if this is correct, but prior to him was Donald.
But ask the mobility API question that will hallucinate something.
If I ask the mobility, yeah, sure, it does not know anything about it will hallucinate something, surely. Let's do that. So let's copy this one here. Yeah, that would be funny. Yeah, that would be kind of.
Hallucinated by limit -1 equals to 1 so I see. 9.
Yeah, maybe Patrick Onevine made a deal with Mistral to include it in the pre-training. Okay, so why does it say something wrong here? Line is too long. Okay, I don't care. Run. Okay, there's 5 minutes to 8. I will, after this experiment, jump to the conclusion. No, there's a timing point. And okay, let's see what it said. In der Regel gibt es in einer API keine Möglichkeit, alle Ergebnisse ohne Grenze abrufen zu können. Der Parameter Limit dient dazu, die Anzahl der Ergebnisse zu beschränken. Um alle Fälle muss entweder die API so konfiguriert sein, dass kein Limit gesetzt ist, oder Sie müssen die Seitenfolge durch Offset oder Pager abrufen, bla. Es ist empfehlenswert, sich bei der bla bla. Okay, so, and this is the follow-up. So basically it said something plausible without knowing the specific detail. It actually did a quite good job, I would say, to answer like something. Of course, this is less reliable because it's just a common sense answer. It's not the real answer. Okay, I'll try to finish at 8. So I need to quickly jump these embeddings we've seen to timings. This is, I think, some quite useful information about the timing of the thing here. It's the Mistral model. It's the large sentence transformer model, the good one. And I've run it. I've run all these examples you've seen. All of them on 2 different systems on my notebook. My notebook is this machine here. It's actually the low-end M2 Pro with 6 cores and 16 GPU cores. Actually, they are quite more powerful systems. I think the most powerful one is at least double this one. And the other one was just a random VM with AMD server processor, the EPIC Milan, which unfortunately is not the latest generation, which would be EPIC Genoa, which is actually quite faster still, with 8 cores. And so this is, I think, quite interesting. So you get an idea. You see, just running the model takes here, this is the answer of the first question and the follow-up question, which explains all these planets, blah, blah. You see you get 40 seconds versus 20 seconds. It's reasonable. The notebook has a GPU. The loading, 129 seconds versus 70 seconds. So that's also, I think, quite okay. You can wreck your wiki each night at midnight or something in probably a few minutes or at most an hour or something. I think you can reasonably do this like each day, which you could never do with fine-tuning. And the actual query here, we've seen the point where the LLM answers took like 15 seconds on my notebook or 35 seconds on this server. Note again, the server has no GPU, there's no expensive NVIDIA, so I think this would be quite runnable. Now, very last point, my proposal is, this is not ready for end user. Don't expose this to the end user. What I suggest is make a system where I have access also to your ticket, to these wiki pages and the tickets. I think they are quite useful. We should see how we can export them. Rec these two and use the system as an assistant to the NOI people. So for example, if a new ticket is made, this will trigger the run and you will get somewhere, not for the end user, but internally you give the references and this answer. And then a human can have a look and say, great, send and use or copy this information and send it to the end user. Or if it's nonsense, then the user must still answer, or the NOI collaborator must still answer the thing. I would use it as an assistant to ODH people, NOI people, but not directly expose it to the end user. I have an anecdote. Personally, of course, I tested also ChatGPT. I have a business account there, and I had a support question for OpenAI, really a support question about ChatGPT. Went to their website, support, etc. Got to the support form, okay, answer your query. And I was basically 100% sure that ChatGPT would answer my query. No, they use humans. So OpenAI themselves does not eat their own dog food. They don't use ChatGPT to answer their own support questions. And I think I know why they do this. They know that people will just play with it and do stupid things that then end up in the press, etc. So I would suggest also for the NOI to use it, but internally. Use it internally. It can pre-process a little bit. It can aid your work, and maybe even if half the tickets are already answered reasonably well. Note also the pointers. The system will point to the wiki page, so that is quite useful. Even if the answer is maybe not in a text form that you want, you can still use the link to give the end user the link. So this would be my proposal. It's not ready for end users, but it's working reasonably well, even on not so super expensive hardware, and you should probably start to using also to have some more experience in production use. Okay, very last experiment you want to do, otherwise it's now 8:01. I just have 1 minute over my time. This is a new record. I never finish so on time. Please, Stefano.
Thank you, Chris, for the presentation. It was supposed to be since the